Imagine being uh, so precise with your words, so incredibly careful about every single syllable you utter, that your colleagues jokingly invent a unit of measurement for silence, and they actually name it after you.
Yeah, it honestly sounds like the origin story of a comic book character or something.
Right. Now imagine that your mind is so deeply connected to the invisible fabric of reality that you predict the existence of antimatter. And you do this years before anyone actually discovers it in a lab.
Which is just wild. But, looking through the biographical records and the scientific papers we have here, it's not fiction. It's the actual historical record of a man whose mind completely reshaped our understanding of the physical world.
Exactly. So today, we're going on a deep dive into the life, the highly unusual mind, and the groundbreaking science of Paul Dirac. He was a British theoretical physicist who undeniably stands shoulder to shoulder with Einstein and Newton. And we've pulled together a really fascinating stack of sources for this. We've got excerpts from his biographical records, his original mathematical papers, historical anecdotes. And our mission today is to use these as a map for you.
Right, because we want to explore how Dirac's intense, almost unrelenting obsession with mathematical beauty allowed him to essentially read the universe's source code.
Yeah, and perhaps more importantly, we want to uncover what his completely unique perspective can teach you about the hidden patterns that govern our everyday world.
The goal here is to really decode why his mind worked the way it did. We need to understand the psychological and environmental factors that forged a brain perfectly suited to untangle the chaotic, bizarre world of 20th century physics.
Yeah.
We aren't just going to list off his scientific achievements, we're going to look at the actual mechanisms behind them.
So to understand how Dirac mathematically mapped the quantum universe, we first have to look at the incredibly strict environment that shaped his legendary silence. The sources start us in Bristol, England, in 1902.
Right. And Dirac's upbringing was heavily defined by his father, Charles, who was a strict Swiss immigrant and a French teacher.
Okay.
Charles instituted a rule in the household that fundamentally altered how young Paul interacted with the world. He forced his children to speak to him exclusively in French.
Now, I read that and initially thought, oh, that sounds like a rigorous language immersion program. But the reality was much, much darker, wasn't it?
Yeah, it was. If Paul made a grammatical error or, couldn't perfectly express his thoughts in French, he was punished.
Wow.
So because he couldn't always find the flawless French translation for what was in his head, he simply chose to remain completely silent.
He opted out of speaking entirely, rather than risk making an error.
Exactly. And this is a crucial piece of his psychological puzzle. He learned from a very young age that expression is dangerous if it isn't completely perfect.
Right.
Which obviously created a profound emotional isolation. And that isolation was compounded by a tragic family event. In 1925, his older brother, Felix, died by suicide.
And Dirac's reaction to this is just heartbreaking. He later recalled that his parents were terribly distressed, and he said, I didn't know they cared so much. I never knew that parents were supposed to care for their children, but from then on I knew.
It reveals a staggering level of emotional detachment in that household. He was in his early 20s before he realized that a parent's love was even a concept.
It's like being forced to learn a computer coding language where a single misplaced comma crashes the entire system. So you just learn to never, ever make a mistake. You just stop typing unless you are absolutely certain the code will run perfectly.
That's a great way to put it.
But I have to ask, do you think this emotionally suppressed, hyper-strict upbringing was actually a prerequisite for his genius? Or was it just a massive hurdle he somehow overcame?
Well, from a psychological standpoint, his father's oppressive role essentially trained Dirac's brain to filter all output through an extreme mechanism of precision and logic. It stripped away all the messy, ambiguous fluff of normal human communication.
Yeah, it forced him to be literal.
Right. So while it was undeniably a traumatic hurdle for his emotional development, it inadvertently forged the exact cognitive toolset he would need to navigate the hyper-complex, unforgiving mathematics of quantum mechanics.
He didn't even start in quantum mechanics, though, which is wild. He initially studied electrical engineering at the University of Bristol.
Right, yeah.
But graduating to the post-World War I depression meant he literally couldn't find a job as an engineer. So he pivoted.
As you do.
Yeah, he got an offer to study mathematics for free, eventually making his way to Cambridge, where he wrote the world's very first PhD thesis on quantum mechanics.
He took the practical, problem-solving mindset of an engineer, combined it with the abstract rigor of pure mathematics, and aimed it at the most cutting-edge physics of the time.
Okay, let's unpack this. because that extreme exactness, born from his childhood trauma, was exactly what he needed when confronted with the fractured landscape of 1920s physics.
It really was a fractured landscape.
Yeah, you had special relativity over here and quantum mechanics over there, and they just didn't speak the same mathematical language.
Right. So we had Schrödinger's wave equation, which worked beautifully for quantum mechanics at low speeds.
Okay.
But it completely fell apart when particles moved close to the speed of light, where special relativity takes over. The equations literally couldn't handle time and space on equal footing.
So physicists were basically stuck trying to force these two frameworks together.
Yeah, and the math was just getting uglier and more convoluted.
This is where Dirac's obsession with pristine logic kicks in. In 1928, he formulates the Dirac equation. But walk me through the mechanics of how he actually did it. I mean, he didn't just tweak Schrödinger's work, right?
No, not at all. He realized the fundamental mathematical structure they were using was just insufficient. To satisfy both relativity and quantum mechanics, Dirac needed an equation that was linear in both space and time.
Okay.
And he found that standard numbers couldn't accomplish this. He had to use matrices, specifically 4x4 matrices.
So he completely changes the mathematical grammar.
Exactly. And by structuring the math this way, the equation naturally accommodated something physicists had been scratching their heads over, which was electron spin.
Oh, right.
Prior to Dirac, spin was just artificially tacked onto equations to make the experimental data fit. But Dirac's matrix math produced spin as an inherent, undeniable consequence of merging relativity and quantum mechanics.
Wait, so the math essentially told him, if you want these two theories to work together, the particle must have this spinning property.
Yeah, the math dictated the reality, rather than human intuition dictating the math. But those 4x4 matrices produce something else. A quadratic equation generally gives you two solutions, right? A positive and a negative.
Sure.
Well, Dirac's math spit out an unexpected extra solution that implied negative energy states.
I am still trying to wrap my head around this part. How does a particle have negative energy? It's like when you take the square root of 4, and the answer is both 2 and -2.
Right.
The math technically works, but you can't have -2 apples in the physical world. Most physicists would have looked at that negative solution and written it off as just a mathematical glitch.
And many of them did just that. They assumed it was an artifact of the calculation with absolutely no physical meaning.
But Dirac didn't.
No, Dirac trusted the math. He proposed what we now call the Dirac sea. He envisioned a vacuum not as empty space, but as an infinite ocean filled with electrons occupying these negative energy states.
Okay, I think I follow.
And if you bump an electron out of that sea into a positive energy state, it leaves behind a hole.
And that hole would act exactly like an electron, but with a positive charge.
Precisely.
Yeah.
He formally predicted the existence of this mirror image particle, the positron, which is the antimatter counterpart to the electron.
Just from the math.
Just from the math. And 4 years later, in 1932, experimental physicist Carl Anderson was looking at cosmic rays in a cloud chamber and observed a particle curving the wrong way in a magnetic field. It was the positron. Dirac predicted a fundamental building block of the universe entirely through pure thought.
That is just staggering. And he also did foundational work around this time on what we now call Fermi-Dirac statistics, which describes the behavior of fermions, a term Dirac himself actually coined.
Yeah, and to understand why fermions matter, we have to look at what they actually do. Fermions are particles with a half-integer spin, like electrons.
Okay.
And Fermi-Dirac statistics mathematically describe how these particles distribute themselves across different energy states.
I know this connects to the Pauli exclusion principle, which dictates that two fermions can't occupy the exact same quantum state at the same time. But how did Dirac statistics turn this abstract rule into a practical model for how matter actually behaves?
Well, because electrons cannot share the same exact state, they have to stack on top of each other in different energy levels. It's kind of like people filling up the floors of a hotel. Fermi-Dirac statistics provide the precise mathematical distribution of how that stacking happens at different temperatures. It fundamentally explains why some materials conduct electricity, why some are insulators, and why some are semiconductors.
Which brings us to his really unapologetic pursuit of mathematical beauty. Because trusting that extra antimatter solution wasn't just a lucky guess. Our sources have this incredible anecdote about this.
Oh, the Moscow one.
Yeah. While visiting Moscow State University in 1956, Dirac was asked to summarize his philosophy of physics. He walked up to a blackboard and wrote, "Physical laws should have mathematical beauty." And apparently, That phrase has never been erased from that blackboard.
Yeah, for Dirac, mathematical beauty wasn't just a nice aesthetic bonus, it was the ultimate compass. If an equation was elegant, simple, and logically pristine, he believed it was much more likely to be true than an ugly equation cobbled together just to match experimental data.
He didn't care about the messy reality if the math was pretty.
Exactly. He flatly refused to engage in the endless philosophical debates of the era about how to interpret quantum mechanics. Whether the cat is dead or alive didn't interest him. He just wanted to focus on the fundamental math.
That obsession with beauty was a double-edged sword, though, wasn't it?
If we connect this to the bigger picture, it became his greatest limitation. Later in his life, physics moved into quantum electrodynamics, or QED, to understand how light and matter interact.
Right.
But when physicists tried to calculate the self-energy of an electron using QED, the equations yielded an infinite number.
Which obviously breaks the math. I mean, you can't have a particle with infinite mass or charge.
Exactly. So to solve this, the physics community developed a mathematical workaround called renormalization. It essentially involves subtracting an infinite quantity from the infinite result, leaving behind a finite, measurable number that miraculously matches experimental data to astonishing precision.
It's like an architect who refuses to use duct tape and superglue to temporarily fix a crumbling building, preferring to let the whole thing collapse rather than compromise the purity of the original design. He would rather have no answer than an ugly answer.
He called it not sensible mathematics. He argued that you can't just ignore a quantity because it happens to be infinitely great and you don't want it in your equation.
He really stuck to his guns.
He did. He essentially alienated himself from the mainstream of theoretical physics for decades because he refused to accept renormalization. He demanded absolute structural integrity from the universe.
Well, when someone is that dedicated to pure logic, the messy, illogical human world becomes almost impossible to navigate, which leads us to some of the most fascinating aspects of Dirac's life, his quirks, his social life, and his views on the divine.
What's fascinating here is how his colleagues quantified his extreme detachment. We mentioned the Dirac unit earlier. His colleagues at Cambridge defined it as a unit equal to 1 word per hour.
That is hilarious.
And that was his genuine average rate of conversation in social settings.
The stories of him interacting with other legendary physicists are just brilliant. The great Niels Bohr once complained to Dirac that he was struggling to finish a sentence in a scientific article he was writing. Dirac just looked at him and replied, "I was taught at school never to start a sentence without knowing the end of it."
Total premeditation, no wasted effort, no room for error. It's the exact linguistic filter his father beat into him, applied to casual conversation with a Nobel laureate.
And then there's the ocean liner anecdote with Werner Heisenberg. In 1929, they were both young, unmarried, and sailing to a conference in Japan. Heisenberg was known as a bit of a ladies' man, flirting and dancing on the ship, while Dirac was just suffering through every social interaction.
He was miserable.
Yeah. Dirac finally asks a companion, "Why do you dance?" Heisenberg says, "When there are nice girls, it is a pleasure." Dirac genuinely ponders this, processes the logic, and blurts out, "But how do you know beforehand that the girls are nice?"
Dirac approached social interaction as an equation with unknown variables. You cannot empirically know a person is nice before interacting with them. Therefore, the premise of dancing to find out is logically flawed.
He was also wildly modest, wasn't he?
Oh, incredibly. He developed an equation for the time evolution of a quantum mechanical operator and insisted on calling it the Heisenberg equation of motion.
Giving away the credit.
Yeah, and even though he co-developed Fermi-Dirac statistics, whenever he lectured on the topic later in life, he insisted on calling it just Fermi statistics.
He had zero patience for anything outside the realm of literal truth. His critique of J. Robert Oppenheimer's interest in poetry is legendary.
Oh, the poetry quote is great.
He told Oppenheimer, "The aim of science is to make difficult things understandable in a simpler way. The aim of poetry is to state simple things in an incomprehensible way. The two are incompatible."
This rigid literalism heavily influenced his early views on religion, too. At the famous 1927 Solvay conference, there was a debate among the younger physicists about religion. Dirac was fiercely critical, arguing that religion was just a political tool devoid of any logical basis.
Right.
Wolfgang Pauli listened to Dirac's intense atheist arguments and finally joked, "There is no God, and Paul Dirac is his prophet."
Here's where it gets really interesting, though. His views actually evolved. Later in life, in 1963, he wrote an article softening this stance significantly.
Really?
Yeah, he stated that if you accept that fundamental physical laws are described by mathematics of great beauty, you could describe the situation by saying that God is a mathematician of a very high order. He even stated that if the origin of life was mathematically highly improbable, then a divine influence must exist.
Wow. It highlights a subtle shift. He didn't find traditional religion, but he conceded that if the universe is dictated by such pristine mathematical architecture, his mind couldn't rule out the existence of a grand architect.
Now, navigating the human world alongside this massive intellect obviously required a very special partner. He married Margit Manchie-Wigner, the sister of another famous physicist.
Right, and Manchi took over the entire logistical, social, and practical operation of his life. One physicist actually noted that Dirac was able to maintain his research productivity only because Manchi was in charge of absolutely everything else.
I have to wonder, is it possible his extreme detachment from humanity was the only way his mind could process the universe? Like his brain simply didn't have the RAM for small talk because it was utilizing all its processing power to calculate the fabric of reality.
Well, the human brain has finite cognitive resources. If you allocate an unprecedented amount of those resources to spatial reasoning, advanced abstraction, and mathematical logic, something else has to give.
Yeah.
Social intuition and emotional processing were the necessary trade-offs for his unparalleled physical insight.
We really need to emphasize how that insight translates to the real world for you listening. Because despite his extreme social disconnect, Dirac was not just an abstract thinker detached from reality. His invisible math practically built a modern, tangible world.
We talked about Fermi-Dirac statistics earlier and how they dictate the way electrons stack in different energy bands. That mathematics is the literal bedrock of semiconductor physics.
So what does this all mean? Well, if you want to build a transistor, you need to know exactly how to manipulate the flow of electrons across a semiconductor's band gap. And you cannot calculate that without Dirac's statistics.
Right.
The smartphone in your pocket, the computer you are using right now, the entire silicon-based architecture of the digital age, it relies entirely on the mathematical foundation that Paul Dirac laid down.
And his practical contributions extended to global conflict as well. During World War II, Dirac contributed to the British atomic bomb program, the Tube Alloys Project.
Okay, I didn't know that.
Yeah, he wasn't just doing abstract wave equations. He tackled the incredibly complex fluid dynamics of the gas centrifuge.
Walk me through what a gas centrifuge actually does and how Dirac's math improved it.
So when you want to build an atomic weapon or a reactor, you need to enrich uranium, which means separating the highly radioactive uranium-235 from the much more common uranium-238.
Because they're basically identical, right?
They are chemically identical, yes, but U-235 is incredibly slightly lighter, so a gas centrifuge spins uranium hexafluoride gas at tremendous speeds to separate them by mass. Dirac mathematically optimized the isotope separation process. His calculations determined the most efficient ways to cascade these centrifuges, and that's a method still used globally today for uranium enrichment.
And he was also decades ahead of his time in theoretical areas that are still cutting edge today. In 1962, he wrote a paper on the Dirac membrane. He proposed treating particles not as zero-dimensional points, but as vibrating extended membranes.
Which mathematically anticipated modern string theory by years.
He even worked on quantizing the gravitational field, essentially predicting that gravitational waves would possess energy density long before we had the LIGO detectors to actually sense those ripples in spacetime.
But despite a life of such intense, isolating mental labor, his later years were surprisingly peaceful. In 1970, he moved to the United States and joined Florida State University in Tallahassee.
Tallahassee, really?
Yeah, and the accounts from this time describe him as genuinely happy. The rigid, silent figure from Cambridge softened. He would walk a mile to work every day, swim in the local lakes, and actually socialize with his colleagues over lunch.
That's amazing.
He passed away in 1984, and there's a telling coda to his story. After his death, there was a movement to put a memorial plaque for him in Westminster Abbey alongside Newton and Darwin.
Oh, that makes total sense.
But the Dean of Westminster initially refused, specifically because of Dirac's reputation as a vocal anti-Christian from that 1927 Solvay conference debate.
Oh, wow. So they held on to that.
Yeah, it took 5 years of persuasion from the scientific community before the dean finally relented. Today, there is a marker in Westminster Abbey inscribed with the Dirac equation.
Lev Landau, the great Russian physicist, famously ranked theoretical physicists on a logarithmic scale of productivity and genius. He gave Einstein a 0.5, and he gave Dirac a 1, placing him in the absolute highest tier of historical physicists.
Looking back at the sources we've unpacked, it's honestly hard to argue with that ranking.
So, to recap our journey today, we've explored how a painfully silent boy from Bristol, trapped in a house of strict linguistic rules, evolved into a scientific saint. He was a man who discovered antimatter not by peering through a microscope, but by trusting a negative sign in a 4 by 4 matrix.
Right.
He refused to compromise his vision of mathematical beauty, alienating himself from his peers rather than using mathematical duct tape. Yet in doing so, he quietly laid the unseen foundation for quantum field theory, nuclear energy, and the very electronics that power our modern lives.
As we close out this deep dive, I want to leave you with a profound, lingering question inspired by Dirac's incredible life. Think about this. Dirac didn't discover antimatter by observing the physical world. He discovered it because the mathematical equations on his paper demanded that it had to be there.
Which is still crazy to think about.
It is. Which leaves us with a staggering question to mull over. Did humanity invent mathematics as a cognitive tool to simply describe the universe around us? Or is mathematics the universe's actual source code, and we are just slowly, generation by generation, learning how to read it?